Every time you look up at the sky and see a star, you are glancing at a glowing sphere of superheated gas which is bigger than any planet, and each star has a story to tell. The formation of a star begins at the denser parts of the universe, where a cloud of dust and gas will begin to contract under the force of gravity. Eventually, enough material will be collected into a massive sphere with a center whose temperature is increasing, and this is due to the collisions of the particles. When it reaches a temperature of about 15 million degrees, a marvelous event occurs. Hydrogen atoms join together, creating a new element known as helium. This process, known as nuclear fusion, causes the ball of dust and gas to glow, and now a new star is born. The energy which is released from the fusion of hydrogen atoms opposes the inward force of gravity, and when both forces are equal, the star reaches a stable size. However, the star will eventually run out of hydrogen, and then gravity will begin to crush the star. It is predicted that our sun will reach its desperate stage in about 5 billion years, so we will probably be long gone by then. I hope so, at least. When the hydrogen runs out, the star contracts inwards, heating up to a temperature of around 180 million degrees, allowing helium to fuse into carbon. The helium fusion reactions cause the outer shell of the star to expand, therefore increasing it in size and decreasing its surface temperature. The star has now become a red giant. At this point, the outer layer of the star is held in weakly by gravity, so much so that in a process known as helium flash, the material surrounding the core is ejected away. This leaves behind a remnant known as a white dwarf, which is a very dense bright core. The white dwarf has the same volume as the Earth, but with a mass that is 300,000 times greater, and over time it cools and dims, fading away into the vast universe. This happens for a star which is the same size as the Sun, but for much bigger stars, well, they go out with a bang. A bigger star will swell up to become a super red giant, and when it collapses to form a white dwarf, its gravity is strong enough to cause it to collapse even further. Electrons combine with protons to create a solid neutron core. Suddenly, the outer shells of the core collapse inwards violently, rebounding against it and generating a shockwave. This causes the star to explode as a supernova. A supernova is a star that increases significantly in brightness as a result of a cataclysmic explosion that gets rid of most of its mass. If the star is even bigger, the supernova leaves behind a massive neutron star that continues to collapse even further, forming a black hole.